The view contains three sets of elements. The first element is the toolbar, now styled in white. The second set is a view reminiscent of the Today view. And the third set contains additional weather detail. Some quick measurement shows that the top set of Today elements is 1.5 times the height of the bottom half of the detail elements. Sounds like a job for a linear layout with weights. Inside of the sets, we see some interesting Android layout techniques. Two spacer views are in place above and below that vertically center the contents of the Today-styled view. Following the rules of material design, we see 16 dp spacers being used liberally in the vertical direction, along with 32 dp spacers in the horizontal direction for the details. But we're still missing the core of these layouts. It would be pretty easy to build the top one with a nested linear layout, and slightly tricky with a relative layout. But it turns out that both of these sections are built with only one layout each, a grid layout. Grid layout was added to Android for the ice cream sandwich release. Its goal is to address the limitations of Android's nested layouts, which fall into three basic categories. Firstly, the inability to control alignment along both axes simultaneously, performance problems and hierarchies that are too deep, especially when you're using expensive features such as layout weight, and unsuitability for design tools that support freeform editing, and yes, we are looking at U relative layout. As its name suggests, grid layout uses rows and columns to lay out views. You can see it adjusts the grid automatically as controls in the right-hand column get larger. Using grid layout, you give constraints to each view as well as specify what to do with the extra space in the cell, using the grid layout's own version of layout gravity. The grid layout then attempts to preserve the constraints as it solves the problem of laying out the view. Android Lollipop added the ability to grid layout to reapportion space among its child's views automatically using layout weights. Fortunately, the support library lets us use its latest and greatest version of grid layout. Grid layout is a separate support component. It requires a separate entry in your Gradle dependency list. Here are a bunch of layout elements in no particular layout. If we place the layouts into a default grid layout, it behaves similar to linear layout, although it aligns text at the baseline by default. We didn't have to put the height or width of each into the layout XML because grid layout assumes wrap content. Here is the underlying grid produced by this layout. Changing the orientation to vertical makes it perform very similar to a vertical linear layout, and here's the grid produced by that layout. Changing things back to the default orientation of horizontal, but giving the grid layout a column count of 2 causes grid layout to automatically place the child views into columns. Here's the underlying grid produced by this layout. Explicitly setting the icon view to the second layout row, first layout column, causes the grid layout to move the cloud icon to the first column in the second row, and continue laying out all other views from there. Here's the underlying grid produced by this layout. But even better, we can use layout column span to have the date span both of the columns. Here's the underlying grid produced by that layout. Now we can distribute the extra weight across all columns by adding a layout column weight to all of the columns. Note that you need to add this to all layouts in the column in each row for it to have the desired effect. And here's the underlying grid produced by this layout. We can tell the grid layout to center a view horizontally within its cell by adding layout gravity equals center horizontal. By adding this to each layout, we get this effect. Note that the two columns aren't exactly even because we only distributed the extra weight between them. It looks close because they contain similar sized elements. You can really see that in the grid produced by this layout. Material design defines these default styles. These sizes and styles were developed to balance content density and reading comfort under typical usage conditions. Consider using these styles whenever possible, as they will help you make good design decisions. The support library provides definitions for all of these font styles. Here's how you would reference the display for 112 SP style in the text appearance of a text view. We're going to do our best to make Sunshine use as many of these styles as we can while implementing the new design.